And right now I'm going to pass my word to my colleague, Vuk, with his awesome topic. And I believe it would be really interesting. I believe that. So Vuk, please go ahead.
Thank you, Vladislav. Really great presentation. I really loved
Thanks.
it.
Yep.
So let
Good luck.
me, can you stop sharing screen so I can take over? Yeah, great. Thanks. Just a second. Okay, do you guys see my screen now?
Yeah.
Yeah, great. So for those of you who maybe missed the introduction at the beginning, my name is Vuk Stefanovic. I am a UI engineer at Grid Dynamics, and today I'll be presenting the topic of design patterns that are used in front-end development. Sometimes we maybe even use them without even knowing them. So for who is this presentation meant for? It's meant for developers who are relatively new to design patterns, and it's more of a motivation to get you interested in design patterns and see why it can be useful for you to know them. And as for engineers who are already very knowledgeable about design patterns, I would say this presentation will be a bit basic, maybe boring, but then again, it can always be a good refresher if you haven't revisited them in a while. So with that in mind, let's go over the topics that we will discuss. So we will briefly touch about the history of design patterns. After that, we will go over a few popular patterns from a popular book. And after that, if we have time, we will have a short Q&A session. So let's get started. First off, I would like to bring to your attention something I've noticed, and I think it's more prominent in our area of front-end development than probably many others, and that's that we just don't learn design patterns. I think that, of course, that this isn't this doesn't mean that no one learns them, but I think on average that a lot of front-end developers just skip out on learning design patterns, and that's okay, because nowadays we can mostly get away with not learning design patterns and still build web applications, mostly because today we have libraries and frameworks for everything mostly, right? And whenever we want to build something, we would always just check that library or framework, and it would make our life easier. But the reason for that is that most of those libraries and frameworks actually have those patterns baked into them, and that's why they actually make our lives easier for us. So that's why I wanted to present to you design patterns, so that you can see how actually design patterns are the ones who are making our lives easier, and that it doesn't really matter which library or framework you're using, as long as you're okay with design patterns. So first off, a brief history on design patterns. So who invented design patterns? Maybe invented isn't really a good word, because no one really invented them. Maybe a better word for that would be discovered, because you could say like physicists discovered gravity, as programmers discovered design patterns, because through now many decades of software development, through various trials and errors, we simply noticed some similarities in solutions for some common problems in programming, and you could say that those solutions became design patterns as we know them today. But the first person to really describe design patterns as a concept was Christopher Alexander, in his book A Pattern Language, Towns, Buildings, and Construction. But even then, design patterns weren't really that popular until his idea was picked up by four authors called the Gang of Four. And in 1994, they wrote the book Design Patterns, Elements of Reusable Object-Oriented Software. And it was a really big hit. Even to this day, it's considered the holy grail of books for design patterns. And that's really impressive when you think about the book was written all the way in 1994. So that's more than 25 years ago. I wasn't even alive back then, but still the book is very relevant and people even now read it and learn various things from it. And that just tells us a lot about how powerful actually these patterns are. Just think about it, how many frameworks and libraries were created at that time, how many died by now. But even though frameworks and libraries may change, it seems that design patterns stay mostly the same. And if this name is too large for you, the short name is the Gang of Four book. So this is what you actually get when you Google Gang of Four, not to mistake it with a popular punk band. This is actually our OG Gang of Four of programmers. So this was our short history lesson. And now we will cover some design patterns that were actually mentioned in this book. There are a lot of patterns in the book. They mention actually 23 patterns, but because of the limited time, we will only go over a few of them here. So the first one is the factory pattern. So what are the use cases for the factory pattern? The factory pattern is good when we have some complex object or component set up with some high level of complexity, when we want to easily generate different instances of objects, and when we work with many objects with same properties. But what does that mean? This is all good in theory, but maybe it would be easier to understand with an example or analogy. So let's pretend that Grid Dynamics is no longer an IT company. We've branched out and now we are making pizzas, and that's our main source of income. So we are now a pizza company, and also other IT giants are now pizza companies as well. And we gave our programmers a task to make us a function that will actually gift pizzas to employees to make them happy. So this function would actually need to specify the company and the type of pizza, for instance, like Grid Dynamics pepperoni pizza. And it would need to create that pizza, bake it, package it, and then gift it to an employee. So how would that code look like? We might be tempted to make something like this, for example. So here is our gift pizza to employee method. It accepts two parameters, the company and the pizza type. So for instance, here we can see if the company name is Grid Dynamics and the type is pepperoni pizza, then we will instantiate our concrete class of Grid Dynamics pepperoni pizza. And in case it's something else like Facebook and veggie, it will be Facebook veggie pizza. And once we actually created our instance, we then bake it, package it, and then return it. And this is fine and all. I mean, this is valid code. It will work, but it's not really a best practice, because in doing this, we are breaking some very important programming principles. Some of you who might have read some books on design patterns probably saw this principle, and that's that we should program to an interface and not to an implementation. And by instantiating these classes in the way we are here, we are actually breaking that principle, and we are programming to a direct implementation and not an interface, which is bad. So you could say that this code is smelly. It gives off a bad code smell. So what can we actually do to make this code better? So if we try to respect the principle, we could try to do something like this. So now we have, again, the same method, so give pizza to employee, but we have two new classes. We have a Grid Dynamics pizza store and the Facebook pizza store. And now these classes for pizza stores are actually the ones responsible for getting our pizzas for that company. So if we ever need some type of Grid Dynamics pizza, we would call the order pizza method on the Grid Dynamics store, and it would actually return that pizza for us. And now we are no longer programming to an implementation, we are programming to an interface here. And the benefit to this is that code is simply easier to maintain and it's more decoupled. So previously, this is okay because we only have 2 pizza types. But imagine if we had like 10, 20, 30 pizza types, this code quickly gets hard to maintain. And also every time that we want to add, remove a pizza, we need to change the code in this method. In this way, we solve this problem. So let's look at the code for the pizza stores. So this is the code for our pizza stores. So we would have a base class pizza store, which has 2 methods, the order pizza method and the create pizza method. So the order pizza method is actually responsible for creating the pizza, baking it, and packaging it. And we leave the actual creation of the pizza to the concrete instances. So for instance, Grid Dynamics Pizza Store, it will be the one who implements this pizza method. And only here will we actually instantiate the concrete classes. And in this way of programming, every time we need to make a change, for instance, add or remove a pizza store, we would only need to do it here, and the code on the left would remain unchanged. So this pattern is actually called the factory method pattern, which is one of the factory patterns. There is another one called abstract factory, but it's a little more complex and we will not be going over it in this presentation. This is a UML representation of the pattern. As you can see, we have 2 actors. We have the creator and we have the product. So the creator is actually responsible for creating the product, and the product may have some methods that concrete products will implement. So this is a side-by-side comparison of the generalized and from our example. So in our example, the pizza store is actually the creator, and it's actually creating the pizza, which is the product. And our concrete pizzas, Grid Dynamics pepperoni pizza and Facebook pepperoni pizzas, need to implement bake and package methods, whereas concrete stores need to implement the create pizza method. So this is it for the factory pattern. But first, I want to show you like some examples in frameworks where we can see factories. For instance, in Ember.js, if we have factory 4, which is actually a public API, and in Ember we have lots of entities like services, components, and a lot of other stuff. And factory 4, if we specify like give me the factory for this full service, it will actually return the factory that we can actually use to instantiate instances of that entity. So we can use factory create to actually create the instances of this service. And this is mostly used internally in the framework, but you can also use it if you ever need it. Similarly, React also has a create factory method. It's also discouraged to use it by yourself. Usually, if you're writing JS, probably it would be used, but it's discouraged to write it yourself. So this is for a factory. Now, the next one is the composite pattern. This one I think is pretty simple to understand. So it's basically used when we have to implement some tree-like object structures and when we need to treat both complex and simple elements uniformly. But what does that mean? Again, I think it will be simpler to explain with an example. So the participants in our example will be components, leaves, and composites. So basically the component is the one that declares the interface for all of our objects in our composition. The leaf is like the leafmost object, so it can have children. And the composite, it's like a branch in our tree, so like a subtree, and it can contain children, and children can be other leaves, or they can be composites also. So analogy for this would be like a big box, right? Inside of a big box, we can find some other smaller boxes. And then inside those boxes, we can have other smaller boxes. And then once we reach the end, we have some leafmost item, like in this case, it's a phone, right? So the boxes are composites and the phones are the leaves. And As front-end developers, it's really important for us to know how to work with tree-like structures, because I think that the one tree-like structure that we all always work with is the DOM, right? And because of that, all of our frameworks and libraries, when we make components, they are all in a tree-like structure. And because of that, it's useful to have a pattern to traverse that tree and perform some operations on all of the components. So this is how we can do that in a code example. So we would have a base component class. It would define methods for adding, removing components, and the operation method, which is actually used to perform some operation. The leafmost component, it only needs to implement the operation. It doesn't need to implement add nor remove methods because it can't have children. But the composite, as you can see, has both add or remove methods for adding and removing children. But also what's most important is inside of its operation method, what it actually does is it loops through all of its children and performs operations on its children. And then it uses that as a result for its own operation. So as you might guess, this is really important when we are traversing tree-like structures. For instance, if you think about some front-end frameworks where we have components, you would always have some topmost component, right? And then when let's say in like React terms, when we render the topmost component, its render method gets called, right? And then it will call the render method of its children, exactly the same as here in operation. We call operation on all children, and then it will propagate all the way down to the leafmost components. And that's why actually all frameworks internally use this composite pattern. So if you're ever building your own framework or something like that, you'll probably find this pattern helpful. This is a UML class diagram. Again, it's pretty simple. So we have our component, which is an abstract class. We have leaves that only implement the operation, and we have add and remove methods on the composite as well as the operation. And now the next one is the command pattern. I think this one will be pretty interesting to you. I think this one was for me. Basically, we use the command pattern when we want to save some operations inside of objects and then be able to queue them, schedule them for later execution, or implement some reversible operations. It's very good when you need to detach like method invocation from actual logic. So another analogy, let's imagine we are inside of a restaurant and we are the client and we want to make an order. We want some pizza and some Pepsi. So we would make an order, right? And the order would be our command. Then a waiter would come, he would take our order, write it down, and after that, he would pass it along to the chef, who actually knows how to make the stuff we want. So because of this, the actual user, he doesn't need to know anything about how pizza is made. He only needs to know what exactly he wants, and then he will delegate the actual work to someone else. So to maybe easier understand the code examples, we will first go over the diagram. So this is the diagram for the command pattern. So we have a couple of actors here. The client is the same as the client in the example, and the client is making some command, right? So because of that, we have a command interface, and we have some concrete commands that the client will create. And as in our example, the command is passed to the waiter, right? So the waiter in this example would be the invoker. The invoker has a method to actually save the command and then execute it from itself. Once the invoker actually executes the command, it will call the command's execute method, which will actually perform some actions on a receiver. So the receiver is actually the one that knows what to do with that command. So he would have some of that business logic. And in the previous example, the receiver would be the chef, right? Because he knows how to make everything. And a good example for usage of command pattern is for remote controls and video games. Because if you think about it, every time we press a button for a video game or for a remote control, what we're actually doing is we are sending a command to our video game to perform some action. So what we could do, like in a vanilla JavaScript implementation, we could have a video game character that would act as our receiver. So the video game character is actually the one who knows how to perform certain actions, like a fire spell and a healing spell. And then we would have a spell command. The spell command would have like which character it is, which action it is, and how many magic points you need to actually perform that spell. But the actual command would come from the user, right? When we click the button, it will actually generate that command. And then once it's executed, so it can be like a fire spell or a healing spell, we will perform certain actions on our receiver, so the character. So perform a fire spell or perform a healing spell. So if you take a look at this code like this switch statement in case of some actions, if you're React developers, you probably see something similar, and that's that it reminds you of Redux, right? And you would be right, because Redux is heavily inspired by this command pattern. It also uses some other patterns, but I think that the command pattern is pretty obvious, and we can actually rework our previous example in Redux terms. So what would we have? We would have some sort of action creator, right? And the action creator is the command. And what is a receiver? The receiver would be the reducer, right? Because the reducer actually houses all of our business logic that is needed for the state to change. And the invoker would be the component where we actually invoke this. So once we click on a certain button, we would dispatch a fire spell. So in this case, dispatch from Redux is the execute method of our command, right? And it's when we execute the command, we actually go to the receiver. So as you can see, Redux is heavily inspired by the command pattern. And if you remember previously, when I said when do we use command patterns, do you maybe find something similar when we need to queue operations, we need to implement reversible operations? It's also something Redux is pretty good at. We have some libraries for like Redux redo and undo and stuff like that. So this was everything that was meant to be covered for this presentation. Are there any questions? Yeah, that's so. Do you think it's more helpful to learn patterns or anti-patterns? I would say both are helpful, but I think that if you learn patterns, if you learn how to do things, it will be easier for you to notice when something is being done in an incorrect way. So I will probably go with learning patterns, and by knowing them, you'll probably be able to notice if someone is performing an anti-pattern for something. I hope that answered your question. Any other questions? Anyone? Okay. In that case, I think that's it. Thank you all for listening. I think we can wrap it up. Thank you, Vladislav, for your presentation. And I think that's it. do you want to say something for the end, Vladislav?
Yep, sure. Thanks, Vuk. I've had a great time listening to your presentation, and so I believe our public was. Thanks a lot, guys, for joining and finding some time to watch our tech talk. And we'll wait. We'll stick to the updates and see if we'll have the next dynamic talk with us. So keep in touch, in sync. Thanks a lot.
Thanks, Vladislav. Actually, I would like to answer. I just saw another question. So before we leave, I would like to answer another question. So Anonymous attendee asked, what are the most obvious patterns used in Angular? So I am not an Angular developer, so I can't really be sure. But from what I know, I think the most obvious pattern is the observer pattern used in Angular. It's the way the state, I think, is mutated in Angular, and also if you're using libraries like Rx, JS, and some other stuff, I think that they are mostly influenced by the observer pattern in the way you subscribe to observers. I see someone wrote dependency injection. Yeah, that's also used in Angular, but dependency injection, I think it's more its own thing. It's not really like maybe a design pattern. I'm not sure what I would call it exactly. But yeah, I think observer is mostly used in Angular. So any more questions? Okay. Then again, thank you all for listening. Hope you found it interesting, and see you next time.
See you.
Bye, everyone.
Goodbye.